So for the second solution, we will be using two formulas. Oh my gosh, wala may formulas. Hey guys, so in this video, we will be solving a problem that talks about the linear speed on the surface of the Earth.
Earth rotates on an axis through its poles. The distance from the axis to the location on Earth, 40 degrees north latitude, is about 3,033.5 miles. Therefore, a location on Earth at 40 degrees north latitude is spinning on a circle of radius 3,033.5 miles. Compute the linear speed on the surface of Earth at 40 degrees north latitude.
So in order to solve this problem, we will be using two solutions. So for the first solution, which is easier and faster because it only uses one formula, which is the linear speed. First, we will define what a linear speed is. So the linear speed is a measurement. It measures the concrete distance of a moving object. So we will now be knowing what the formula of a linear speed is. Linear speed v is equal to the distance traveled over time. So we all know that in 24 hours, there is one complete rotation. So the rotation is equal to 2 pi of a circle. That is why we will be using 2 pi here. 2 pi over the time, we'll be using 24 hours. 24 hours also shows the constant speed at which it is traveling. So when we calculate this on the calculator, so 2 pi over 24, it will give us an answer of 0.262. And then we will be multiplying this by r. Okay, so the r, which is given in the problem, is 3,033.5 miles. 0.262 times 3,033.5 gives us a linear speed of 794.17 miles per hour. So we used per hour because of this 24. So that is the linear speed on the surface of the Earth using the linear speed formula. So for the second way, in order to solve the problem, we will be using two formulas, which is the angular velocity and the linear velocity. So what is a linear velocity? So the linear velocity is the rate of change of the position of an object moving on along a straight path. Any object that moves has linear velocity. So on the other hand, the angular velocity is the rate of change of the angular displacement over time. It only applies to objects moving on a circular path. So we will now be I will now be writing the formulas of the angular velocity and the linear velocity. So for the linear velocity, V is equal to omega times r. We will also use this omega in the angular velocity formula. Angular velocity, W is equal to theta over time. There are actually other formulas of the angular velocity, but we will be using theta over time because it's just like converting 360 degrees into radians. We will be using the 2 pi of a circle formula in order to convert it into radians. Just like in the first solution, we will be using the formula of the angular velocity, which is omega over 2 pi over time, the 24 hours, which still gives us 0. We'll calculate it again because I forgot the answer. 2. Oh my god. 2.62. So that is the angular velocity. Then we will be plugging in this answer 0.262 in the formula of the linear velocity, which is v is equal to omega r. This omega is this omega. Yes. So 0.262 times r, which is given in the problem, which is the radius, 3033.5. It will then give us an answer of 794.17 miles per hour, just like in the first solution. So actually, the two solutions doesn't really have that much of a difference. The only difference is that for the first solution, we immediately multiply the radius to the 2 pi in order to get the distance, but it can also be 2 pi divided by the time and multiplied by the radius. It will still get the same answer. For the second solution, it's just that we use the formula of the angular velocity and the linear velocity. So yes, the linear speed on the surface of the Earth, 40 degrees north latitude, is 794.17 miles per hour. And if you're wondering why I didn't use seconds, miles per seconds, it's because we used the 24 hours in our formula a while ago. So thank you for listening and watching, and I hope that you learned something on how to solve the linear speed of the Earth. So I'm Megan Santos, and